Simplifying complex problems is the key to finding effective solutions. The Great Mental Models by Shane Paris. In our previous chapter, we concluded that developing a product involves learning who and what that product is being made for. To facilitate this learning process, we discovered that we needed someone with the domain knowledge to teach us about it, and we concluded the people most suited for this task were the domain experts. We then filled the gaps in the communication that occur when two sides speak in different terminology using the ubiquitous language, and we concluded the video by giving some advice on tools and trade-offs to use when trying to implement domain-driven design in a company. In this video, we are going to explore the problems that arise from having too many mental models and domains in a company, how these can sometimes mix up and create confusion, and how to address this issue in a more effective way. Companies of any size dabble in multiple domains, as we have seen in Chapter 1. Because of this, when making software products for them, it is likely that in your product, you will have to represent mental models that belong to different contexts and domains. Imagine, for example, that you are working for a food research company that invents new meals. In this company, you have chefs that cook and botanists responsible for making sure all plants are grown with specific modifications in mind. In this scenario, the tomato is considered a fruit for the botanists, but for the chefs, it is considered a vegetable due to its savory profile. If your application had to represent both mental models, what would you do? Would you create a big model to represent everything? Representing the mental models of your domain experts in one catch-all model would raise several problems. First, you wouldn't know when tomato is meant to be addressed as a fruit or a vegetable. You could in theory fix this by adding a prefix to the word, ending up with cooking tomato and botanic tomato. If this sounds strange, it's because it is. Not only don't normal people talk like this, it means you are also adding extra complexity to the term by adding extra context to its definition. Second, even if you were to make such a convoluted amalgamation of domains and concepts work, you would end up with a gigantic model representing concepts from several mental models from different domains. You would end up with a model that is a jack of all trades, but terrible at representing any one of them individually. To this effect, domain-driven design suggests a different approach: divide and conquer. In this specific case, you would divide your model into smaller submodels, one for each context. You would therefore end up with a model for the chefs, where tomatoes are considered vegetables, and a model for botanists, where tomatoes are considered fruits. This approach is commonly known as the bounded context pattern. You divide a big model into multiple submodels, each one with a well-defined boundary. As a consequence, every time you talk to a domain expert, you make clear which context you are assuming to avoid any confusion. Because we are subdividing our model into multiple smaller submodels with bounded contexts, our language needs to reflect this. As such, each submodel will have its own ubiquitous language. This way, we enforce the link between language and models. Our ubiquitous language is the tool of choice to represent all the concepts of the submodel, and is therefore as specific as the submodel is. Consequently, an ubiquitous language for a context A is irrelevant for context B, and so are the terms and concepts it defines. In conclusion, ubiquitous languages are only ubiquitous within the bounded contexts they apply to. It is important to note that the consistency of the ubiquitous language helps only to identify the widest boundaries of the bounded context. If the context is larger, then the language representing it becomes inconsistent, and this works as a nice alarm to know when any given model is becoming too large. However, nothing is stopping you from further decomposing a model into as many submodels as you want. The only warning sign here is that the more submodels you have, the bigger the integration overhead between them. Should you reach a point where the costs of the integration overhead outweigh its benefits, then you have probably divided a model too much. Being big or small does not make a consistent model good or bad. It is its usefulness that decides that. So as long as you define your boundaries with a strategic mindset, creating more models when you need to narrow down specific problems or allowing a model to grow when you don't need as much detail, you will find your balance. With this in mind, Kononov does offer some suggestions on when to decompose models. 1. When creating new software engineering teams. 2. When addressing systems' non-functional requirements, like separation of development life cycles. And finally, 3. When you want some piece of functionality to scale independently from other bounded contexts. The author also warns against decomposition in excess, using as a warning the situation when developers try to decompose a piece of coherent functionality, usually represented by a set of related use cases. Doing this will create a shotgun surgery effect when refactoring code, as any change to a bounded context will immediately affect and require changes in all the other neighboring bounded contexts. But how does this fit together with domains and subdomains? We may have long past Chapter 1 where these concepts were introduced, but rest assured, they are connected. You see, a company's domain and subdomains are discovered, meaning that business decides what to focus on, and we as engineers need to understand what is the company's main focus and what supports that. On the other hand, bounded contexts are design choices that we as engineers do. We could have a one-to-one mapping between subdomain and bounded contexts, or we can have a subdomain harbor multiple bounded contexts. We decide what makes our lives easier. We decide what is the design that best fits. In a company that is very small, you can have one bounded context to represent everything, the core domain, and all the subdomains. In bigger companies, we may have several bounded contexts for one single subdomain. As Kononov puts it, domains are discovered, bounded contexts are designed. But with all this talk about bounded contexts, how do we implement them in our day-to-day jobs? Kononov defends that bounded contexts, besides defining the theoretical boundaries between models, also define physical and ownership boundaries. In the case of physical boundaries, each bounded context should be implemented as a separate project, which evolves and is versioned independently from other projects. Doing things this way means that each context can then have the tech stack that best suits its needs. Subdomains that span multiple bounded contexts will have multiple projects, one for each context. On the other hand, if a bounded context encapsulates multiple subdomains, then we will still have only one project, but inside the project we will have different modules or packages, whatever the logical boundary your language provides, to represent each one. As for ownership boundaries, it reveals itself given the physical boundaries previously discussed. A team can own multiple bounded contexts, i.e., projects, but no bounded context can be owned by more than one team. This makes the team creating and evolving the projects the owners of said projects and consequently the sole owners of the respective bounded context. In the end, a project owned by everyone in the company is a project owned by no one. Domain-driven design eliminates this issue at the core. In this last chapter, it is important to re-emphasize that bounded contexts represent models, which are in their essence simplified abstractions of reality. As mentioned in the previous video, An excellent example of models are maps, but there are other examples one can think of as well. For example, in economy, the GDP, gross domestic product, is used as a model to predict how well a given country or region is evolving over time. If this is a model that you believe to be relevant for the well-being of the population of said country or region is up to you, but it is nonetheless a simplification of reality with a specific purpose. In architecture, a building of Lego can be seen as a simplification of reality, allowing the architect and city planners to understand if the project at hand will connect properly with the existing infrastructure and how it will affect the population around it. If you have endured this essay until now, you probably get the point. Models and the bounded context that represent them are not only all around us, they are an essential part on how we understand the world. And we have arrived at the end. In short, this chapter can be summarized in a few bullet points. Conflicts in the domain expert's mental models generally signal the mental model in use is inconsistent and needs therefore to be decomposed into smaller bounded contexts, each with its own ubiquitous language. Subdomains are discovered, but bounded contexts are designed. Bounded contexts are implemented by projects. A team can own multiple projects, but no project should be owned by more than one team. Because bounded contexts evolve independently from each other, every new bounded context will add integration overhead with other bounded contexts. With this fresh summary in hand, it is time to, once again, bother you with my personal experiences and opinions. I would like to start with the author's suggestion that bounded contexts should be single projects. Upon discussing this exact point with colleagues, an interesting question came about. What is a project for you? In my mind, a project is a GitHub repository. But this may not be enough. A GitHub repository can be many things, depending on how you organize your code. Some people may consider a project to be a GitHub repository of only one monolithic application, while others consider a project to be a GitHub repository with a multitude of smaller applications, like a microservice mesh. The repository may not even be an application, and just a small functional library. Here you need to decide with your team what you consider to be a project, and then maintain a line of consistency in the company. Another consideration with the ownership of said projects. Does this include all the steps, from DevOps to software design to accounting? In some places I worked, I was responsible for calculating and knowing beforehand how much any given project would cost before going forward with it. In other, bigger companies, I was not allowed to do anything DevOps related and could only focus on the software design part. What does it really mean to own a project? What are your obligations? The author, at least for now, does not offer definitive answers to these questions. Nonetheless, I do find them as good starting points for a conversation with your team. And we are finally done with Chapter 3. Join us for the next chapter, where I will discuss integration strategies between different bounded contexts. If you would like to see more content like this, then feel free to like, share, and subscribe. Wish you all the best, and I hope to see you again for Chapter 4.